Hi, and welcome to this presentation of a software architecture called Polylith. I'm going to talk about the background, what Polylith is, how it works, and why you should use it. This is a city, a code city, made by this guy, and it can visualize a code base as a city. And this is the Java Development Kit 1.5, where each building is a class, and the codebase is divided into packages, where the top package here is the Java package, and then we have different sub-packages, and this is where we put our code. And if this was a functional language, we would put our functions in here. But let's pretend now that this is our own code base that lives in a source directory and has a top package here, or namespace. And that we store all our different domains here. It could be like a booking domain that takes care of booking of tools, so that people can borrow and lend a tool, maybe in their neighborhood. And let's say we want to extract this functionality into our own service. Then we need to create a new project, a booking service in this case, with a source folder that will have a top namespace where we can put all the functionality in this service. And this booking service also uses other domains like lender and borrower, and it may communicate with the database, and we have other functionality here too. And we need all this in our new service. In our old service here we have the booking functionality, which are only used from one place, which means that we can now just move this into our new service. And then we can add some code to expose this service as a REST service in this case. And now we can delegate to the new service. But what about the other functionality here? Unfortunately, this functionality is also used by the old service, which means that we can't just copy this or move this into our new service. But yes, we can copy it. So let's do that. But the problem with this is that now we need to maintain the code in two places, which means that if we find a bug in one place, we need to remember to update the code in the other place also. And we didn't manage to share those building blocks between those services. But maybe we can create a library instead. So let's do that. Let's create a new project, booking library, and create a source folder with a top namespace. And now we can move the code into this new project. And if we freeze the code into a library, we can now use this library in our services in this way. And this is good because now we can work with the code from one place here. And we could get rid of the code duplication that we had before. But what happens with our development experience here? Because now when we need to make changes here in our original service, we can't do that directly in our service. We need to go back to the booking library, make a change there, create a new library or a new version of the library, and then we can use that library here. And the same with the other service. When that service needs to change, we need to create a library and use that library. This means that we suddenly are using different versions of our code base or parts of our code base. And there are no guarantees here that the whole code base works actually with the latest version of the code. But this is probably not the biggest problem. The biggest problem here is that by freezing the code, it affects our development experience, so that we can't just make small changes when we work with the code and get immediate feedback. Instead, we need to go to this separate library or a project and create maybe snapshot libraries of this of our changes, and then load them into our services. And this creates a slow feedback loop, and it's kind of painful to work with. To work with the code this way, and I have tried it, so I know. But the good thing here was that we could solve two important problems here. That was to get fast feedback, and other problem was to share code between services. So maybe we can find a third way here. What if we could grow our code? So when we start a new project, we add new building blocks one at a time, and we kind of grow the software this way. And what if we could work with all the code from one place, like this? And what if we could grow the code over time, like growing a garden? That would be really great, wouldn't it? And what if those building blocks were like Lego bricks, so that we could add new services when we needed them, and then just combining those building blocks like if it was Lego bricks. And we could add new services whenever we wanted. And if we could do this very quickly and easily, then we could also grow how we run the code in production. And that would be fantastic, wouldn't it? And this is actually what Polylith is about. So what is Polylith? Polylith is a software architecture, mostly for the backend. It is simple, flexible, and it makes you productive. It contains small building blocks that are easy to reason about, and they are easy to combine into services, tools, and libraries. And they are very composable, just like Lego bricks. They also keep your code base consistent, because we only have one of each building block, so we don't introduce any code duplication here. And they are also very flexible. So the way we extend the code base or grow our code base is by adding new building blocks to it. And they are also replaceable. We can easily replace those building blocks, just like if it was Lego bricks. It also makes us productive. And the main reason is that we can work with all our building blocks from one place, like it was a single code base. And this allows us to refactor our code, debug our code, and navigate our code. And that gives us a really fast feedback loop. And in production, we can change how we execute our code. And this is something we can do very easily, and it takes almost no time. And it also allows us to postpone decisions on how to execute the code in production. So we have this separation between development and production, where in production we we can optimize for non-functional requirements, while in our development environment, we optimize for productivity. And this separation is really important, and this is very core to the whole idea behind Polylith. So how does it work? Yeah, we have our building blocks. One of them is the library, and a library in Polylith is just the library that you already know about. So the same libraries you use all day already. So no fancy about them. And then we have components. Components are blocks of code that a component has a nice name and hopefully a descriptive name, and it lives in a directory that has the same name as the component. And it has 3 directories: source, test, and resources. And it also has an interface, but it's a special interface. So what is a Polylith interface? A Polylith interface is a namespace with a name interface that contains all the functions that this component exposes to other components. And we also have one or several namespaces that implements the functionality. And they contain functions too. And each function in the interface delegates to a function in the implementation. And this is most often just a one-liner, and it passes through the incoming call to this implementation. Components are also very flexible. Components live in a directory called components, and the way we extend functionality is by adding more components to this directory. And that's one way of growing our software. The other way is to add more namespaces to the component. And those components, they are also replaceable. And let's say we add one more component here, Invoicer2. That's a terrible name, by the way. But if that component uses the same interface, in this case it lives in and it uses the same Invoicer interface as the Invoicer component, and if it has the same set of functions, then we can replace one component with another. So if we have a project here, let's say a service, that uses the Invoicer component here, we can replace that component with the Invoicer2 here, because they look exactly the same for the surrounding code. They can't notice any difference here. So that's where we get that's how we get the replaceability, and it's like playing with Lego. The third type of building block we have is the base. And a base is very similar to a component. It's a block of code with a name, a descriptive name, hopefully. And it lives in a directory with the same name as the base. And it has a source, test, and resources directory. And it lives in a namespace with the same name as the component. I mean the base, yeah. And inside here, we have a namespace, and a base exposes a public API to the outside world. And that's the single responsibility for a base. And that could be something like a REST API, a Lambda function, or a command line tool. And if it's a command line tool, we would have a main function. And bases, they are really flexible and extendable. And because bases, they just delegate to other components. And we can extend the functionality by adding more components that a base delegates to. And you never put business logic into a base. You always just delegate to other components. And so a base is just a thin layer between the user of something and the components where the logic is implemented. And the productivity comes from working from a single development environment. And it works like this. We have a single configuration file that specifies all the libraries we use and also all the source folders for all the components and bases that we also use. And when we do that, we are then able to work with all our code from one place, as if it was a single code base. And it works the same in production, with the difference that in production you are allowed to have more than one project. So you can have one project per artifact. And that could be, for example, a service, for example. And if it's a service, then we would have one base that exposes the public API. It could be a REST API, for example. And the components and the libraries, they just implement the functionality for this project or artifact. And why? Why should we use Polylith? I think we have a lot of challenges in the software industry that are not solved yet. For example, sharing code is hard. And we often use the same code in different places in different services, for example. And sometimes we try to solve that by sharing code by using libraries. But none of them really solves the problem. But with Polylith, sharing code is easy. We have our building blocks that we can access from one place but use everywhere. So they are really shareable blocks of code. Growing software is hard also. Today, it's a big challenge. And I think the main reason is that we put our code into places. For example, services. And then when we realize that we want to reuse some part of that code, it's almost impossible because everything is kind of glued together into one place. And you can't just take away one piece of it. But with Polylith, growing software is easy. And we just add one little building block at a time. So we grow our software that way. And then it's super easy to just put those Lego-like building blocks together into artifacts. Another problem is that we don't have a shared language for talking about architectural concepts today. But with Polylith, we have that. We have those high-level concepts like components and bases that have a unique single responsibility, each of them. And a component is a way of packaging your code in a way that it can be reused very easily, and they expose a set of functions, so they are really easy to reason about. And then we have bases. They do one thing. They expose a single. They expose a public API, and so it's really easy to reason about those building blocks. And then we have the projects. A project is also very simple. It just specifies in a single config file what building blocks that are included in that project. So when you come as a new developer to a code base or a new project, then it's super easy, because you just go to the main directory, the workspace directory, top directory for the system, and then it will. This Polylith system, Polylith workspace always have those 4 directories: components, bases, development, and projects. So what you do is that you can expand one of the directories, for example the components, and directly get a good idea of what this system can do, because you have good name on each component. And that makes it easy to reason about the system. And the other thing you can do is to expand the projects directory, because the projects says what artifacts we build out of this code base and how we execute the code in production. For example, if you have a number of services. So we could say that project structure communicates what this code base does and what it can do. And another interesting thing with Polylith is that it changes how you think about software. Today we organize code into layers, and that's something we do because we want to be able to reason about the code more easily and to change the code in a more controlled way. Sometimes we organize the code in onions, but that's also some kind of layers. But what happens when you work with Polylith is that you stop thinking about layers. It's kind of magic almost. You just concentrate on those components. And they can be really small, like a few hundred lines of code often. And what happens is that you just add one more component and you can reason about every component in isolation. And then when you need to decide how to run the code, you can create a base and decide should this be a Lambda function or something else. And then you create a project, and then you just put the building blocks together there. And so our building software become something much simpler than it is today. Another challenge we have today in this software industry is to collaborate on code. But with Polylith, this is easy. A popular way of working with code is to let different teams be responsible for different services. And this is a good way, I think, to work with code. And this is something we can do with Polylith too. Something that is different here is that with Polylith, we can let all our teams work and have access to all our building blocks from one place. So we can share components between teams and projects. And let's say one team can of course have components that only they use, but all components and building blocks are actually shared and available to all teams. So no restrictions. Another challenge we have today is that code is organized for ease of deployment instead of ease of development. And it can work like this. It can look like this. If we have 2 services in production today, we automatically end up with 2 services in our development environment. And every time we add a new service to production, we also add a new service to our development environment, because we use the production code to work with our code. So if we have a lot of services in production, we also have a lot of services in our development environment and test environment and so on. But in Polylith, we organize our code both for ease of deployment and ease of development. And it works like this. So Polylith totally separates those 2 concepts, or those 2 worlds, so that in production we are totally free to run our code in any way we want, and it will not affect how we work with the code, because we always work with all the code from one place to get maximum feedback, or a really short feedback loop. The last thing I want to talk about is that today tests take a long time to run. But with Polylith, tests run fast. And the reason is that we can run the tests incrementally. So if we make a change in one component, we only need to execute the tests for that component and for projects that are affected by that change. And this means that just a small percentage of the tests will be executed every time you run the tests. And this encourages you to run your tests often. And this is a good thing, really good thing. And the same thing happens in production when the tests are executed in our continuous integration server. We get the faster, they run faster there too. To summarize, keep it simple, use small Lego-like building blocks that are easy to reason about and combine. Work fast from a single development environment that gives you a really fast feedback loop. And have fun, because playing with Lego is super fun. I really recommend it. And who made this? This is the Polylith team. It's me, Ferkel and James. And by the way, they are really awesome guys. And this was everything for me. And I hope that your next project will be a Polylith project. So happy coding!